Hi, salam and good morning everyone. I'm from group 8. For this week, we have done experiment which is Bourdon tube pressure. Okay, so this is my group members. So we go to the abstract. So the abstract is this experiment was done to calibrate a Bourdon tube pressure gauge using dead weights. Weights are loaded on the piston and the indicated Bourdon tube pressure was read. In this experiment, the pressure and percentage of error that occurred inside the Bourdon tube will be calculated and compared to the actual pressure that exerted by the total mass. According to the experimental results, the error that occurs in the Bourdon tube is inconsistent. Okay, objective for this experiment is to calibrate a Bourdon tube pressure gauge using the dead weights. Next, the introduction for this experiment, which is instrument calibration, is one of the primary process used to maintain instrument accuracy. It is the process of configuring an instrument to provide result within an acceptable range. Known weights have been applied on a dead weight calibrator to apply pressure to a fluid for checking the accuracy of readings from a pressure gauge. Various types of pressure measuring instruments have been used to measure the pressure intensity at any point in static or moving fluid. One of these devices is the Bourdon tube pressure gauge. Bourdon tube pressure gauges are most widely used nowadays because of their reliability, compactness, low cost, and ease to use. It consists of a curved tube of elliptical cross-section bent into a circular arc. When pressure is applied to the tube, it tends to straighten out, and the deflection of the end of the tube is communicated through a system levers to a recording pointer. This gauge is widely used for steam and compressed gases. The pressure indicates in the difference between the system pressure to the external ambient pressure and is usually referred as the gauge pressure. So I will pass to the next presenter. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Syahmi, one of the member of Group 8, and I will be explain the theory for this experiment. In this experiment, we have using two devices, which is for the Bourdon gauge and the deadweight calibrator. First of all, I will explain about the Bourdon gauge. The essential mechanical element in this gauge is the hollow elastic curved tube, or we call Bourdon tube, which is connected to the pressure source as shown in the picture below. As the pressure within the tube increases, the tube tends to straighten, and although the deformation is small, it can be translated into the motion of the pointer on a dial. Since it is the difference in the pressure between the outside of the tube, which is the atmospheric pressure, and the inside of the tube that causes the movement of the tube, the indicated pressure is gauge pressure. The Bourdon gauge must be calibrated so that the dial reading can directly indicate the pressure in suitable units. Next is the deadweight calibrator. The weight calibrator are one of the measuring instruments used in this experiment. It is a pitted cylinder type measuring instrument for electronic or mechanical pressure measuring device. The weight calibrator are most accurate. The work principle of the device according to the equation P equal to F over A, where P is the pressure X on a known area on the piston A, will generate force. The force then is measured and compared with the force applied by the calibrator weight. The principle using in this experiment, the use of the pistons and weights with the cylinder generates a measurable reference pressure, P equal to F over A and F equal to mg, where F is the force applied to the liquid in the calibrator cylinder in unit Newton, and m is the total mass including the mass of the piston in kilogram, A cross-sectional area of the pistons in meter cube, and g is the acceleration due to gravity in meter per second square. That's all for me, and next I will pass to the methodology part. Thank you.
Hi, my name is Amein, and now I want to explain to you guys about the methodology of this experiment. First, we will go to the apparatus. First, we need to have the Bourdon tube pressure gauge, 1 kg piston, and 10 deadweight tester, 0.5 kilogram. Next, I will explain to you guys about the procedure. The first step is the piston was put into the cylinder. Now air bubbles were ensured in the tube and the reading of the Bourdon pressure gauge was taken. The weight 0.5 kg was added to the piston. The reading of the Bourdon pressure gauge was taken. Step 3 and 4 were repeated for all the weight. After that, all the weight were removed one by one and the reading of the Bourdon pressure gauge was taken. Step 1 to 6 were repeated 2 times to take the average, and the last one is all the readings were recorded in the table 1.
Next, I will present about the result and discussion. Table 1 shows the data from the experiment. For discussion, first we calculated the theoretical pressure, which is the actual pressure, by using the formula force over cross-section area. And we also calculated the pressure when the mass increased by 0.5 kg. Then we calculate the percentage error for loading and also unloading. The same calculation is repeated for the other mass. The figure 1 shows the graph of pressure against total mass exerted for loading. The graph shows that the data of measured pressure and actual pressure differs a lot when the weight is increased. Therefore, the percentage of relative error for the theoretical and measured pressure gauge is large. The percentage error between the measured pressure and the theoretical pressure may be caused by the errors happen when conducting the experiment. Next, figure 2 shows the graph of pressure against total mass exerted for unloading. The graph shows that there is a slight difference in the data of measured pressure and actual pressure when the weight decreases. Therefore, the percentage of relative error for the theoretical and measured pressure gauge is relatively small compared to figure 1. The difference between the measured pressure and the theoretical pressure may be due to the errors when conducting the experiment. Next is the source of error and method to minimize the error. The result obtained is slightly inaccurate due to the instrumental error, and also the error happened during the experiment. Firstly, the inaccuracy in the data may be caused by the presence of air bubbles in the cylinder. This error can be avoided by putting a moderate amount of oil into the cylinder to prevent air bubbles from building up inside the cylinder. After inserting the piston, rotate the piston slowly to remove the air bubbles. Next, the parallax error when taking the reading of Bourdon gauge pressure. It is caused by the eye level, which is not directly perpendicular to the scale reading when taking the readings, and this will also affect the accuracy of data obtained. This can be minimized by making sure the eye level is perpendicular to the scale that needs to be read when taking the readings. Besides that, the error also caused by the friction between the piston and the inner wall of the cylinder. When the weight is removed, the pressure should be pushing the piston upwards. However, due to the friction between the cylinder and the piston cannot raise to its designated place. Therefore, this error can be reduced by rotating the piston out slowly after adding or removing the weight, so that the piston can be moved to its place better and is not much disturbed by the friction. Lastly, in order to minimize the error, we should also repeat the experiment several times and also at least 3 measurements for each reading and then find the average. Next is the repeatability and accuracy of this experiment. Firstly, the apparatus is sensitive to shocks and vibration. The reading will be easily affected once we accidentally disturb the table while conducting this experiment. To prevent this to happen, we should be more cautious while loading and unloading the weights. This can be improved by repeating taking the readings for 3 times to get an average result. Secondly, the division of the scale reading of the dead weight pressure gauge calibrator is too big. Therefore, while taking the reading of the pressure, it may be slightly inaccurate because it is not exactly the real value. The scale reading should be more sensitive and have smaller scales so that we are able to record an accurate value. Lastly, when weight is added, the dead weight pressure gauge calibrator responds slowly to the change in pressure and the friction. This can be improvised by rotating the piston to remove air bubbles inside the cylinder tube and to reduce friction to obtain more accurate reading of pressure.
So lastly, for the conclusion, upon considering the varied degree of error during this experiment, this particular attempt is not a reliable method for calibrating the Bourdon pressure gauge. To ensure the proper calibration, measurement tools must have a reliable system setup that does not introduce sources of error to the device. The pressure gauge could not be accurately calibrated in the apparatus used in the experiment due to several sources of error. These sources include but are not limited to leakage, poor lubrication, trapped air, mechanical fatigue, poor weight calibration, differential dead weight masses, and general user error. So, upon repeating this experiment, a truly sealed piston cylinder device should be used along with uniform set of dead weights. In addition to this, a high lubricity fluid should be used instead of water to prevent any resisted motion. With this adjustment, the experiment may be repeated and re-evaluated as a reliable calibration method. So that's all for this experiment. Thank you.